we are to graph this hyperbola. To graph this hyperbola, our first step would be to divide both sides by 1600 so that we can get it in the general form of a hyperbola. So I'm going to divide by 1600 here, and I'm going to divide by 1600 here, and I'm going to divide by 1600 here. When we do that division, we get y squared over 100 minus x squared over 64 is equal to 1. Now remember that a comes first always with a hyperbola. So a is the square root of 100, which is 10. So b would equal 8 because that's the square root of 64. Also, because y comes first, we know that our vertices will lie along the y-axis because our center of this hyperbola is at the origin. So our vertices are going to be 0, 10, and 0, negative 10. With b equal to 8, we can get those other points that will help us form our box to graph this hyperbola. So that'll give us 8, 0, and negative 8, 0 on the x-axis. Now to find c, which will help us find each focus, we evaluate or solve the equation c squared is equal to a squared plus b squared, or c squared is equal to 100 plus 64, or c squared equals 164, and c will equal plus or minus 2 square roots of 41 because of the square root property. That means that our foci, which lie also on the y-axis, will be 0, 2 square roots of 41, and 0, negative 2 square roots of 41. Our equations for our asymptote lines will be y is equal to plus or minus a over b x. If we plug in a over b and we simplify that, we get y is equal to plus or minus 5/4 x. Now plugging in all of these numbers, we will get our graph of our hyperbola. So over here we have our hyperbola with vertices 0, 10 and 0, negative 10. We have our focus, number 1, which would be 0, negative 2 square roots of 41. Focus 2, which is 0, 2 square roots of 41. We also have our points negative 8, 0 and positive 8, 0, which help us form our box here. Then we draw our asymptote lines through the corners of our box and the origin. Remember that the equations for these asymptote lines are y equals 5/4 x and y equals negative 5/4 x. Then we just draw our hyperbola, which would be these solid lines here and here.